Hello guys. So welcome back to another video of machine learning and data science basically. So today particularly we are going to start our NLP series. So in this video we'll be uh, going through it's obviously will be practical, hands-on mostly, and we are going to do the pre-processing step of any NLP project. So what's needs to be done as a basic pre-processing in any NLP projects you need to do, or what kind of things you have to identify for traditional things, right? Later on in this series, we'll see that how LLM can help solving all these problems without using any code. So for now, like with the involvement of OpenAI and Hugging Face and all that, LLM basically chains are coming around. We have LangChains, right? So later we'll see how to write LangChain applications and codes. That will definitely be a much more helpful in solving the problems that we are trying to do, or normally we used to solve using traditional machine learning and artificial intelligence methods. Okay, so I'll quickly, I have taken this from SlideShare, so this is not my slides. I have taken it from Hansi, I don't know how to pronounce. Okay, let's start with the basic of what's NLP and things, right? You already know, so I'll not go into that jibber jabber much more. So as you know that NLP is nothing but processing the information that a text data basically, let's say it can be a text, JSON, CSV, so what it contains, processing that linguistic and getting insights from that linguistics. Okay, so it's also called natural language engineering, computational linguistics, and things like that. Okay, so for machines, what is NLP basically? So they used to analyze, understand, and generate human languages just like humans do, applying computational techniques to language domain to explain linguistic theories, to use the theories to build systems. Started off a bunch of artificial intelligence, some linguistic, psychological, and cognitive science and statistics, and make computers learn our language rather than we learn theirs. Okay, so basically, if you summarize all of these points, it's making your life easier while you are doing some document processing, nothing else. Okay, so I'm not going too deeper in this NLP slides. Okay, so I'm hoping that those who are watching this or listening to this YouTube video basically have already gone through what's NLP and how to do things with NLP. So let's quickly go to, you know, our notebook. So apart from our notebook, let's say what we are going to do. Okay, what we are going to do in this notebook. So that's more important. So first thing first, we'll be doing tokenization of words. Second, we'll be doing, so this is what a standard pre-processing includes basically. Okay, so first we'll be doing a tokenization, then we'll be doing let's say removal of stop words or removal of unwanted features from sentences. And let's say the third one, what we want to do is, let's say, to get an understanding of what is this n-gram concept is. Fourth, we want to understand what's my stemming. Fifth, we want to get a deeper understanding of what a count vector. Vector spelling is wrong, vector, right? Then we'll be requiring definitely a what's my TF IDF, and the last one that we'll be doing, probably let's say understanding what's our WSD. Okay, that means that we'll understand the context based on which then later we have evolved our deep learning framework, which is our transformer. And then let's say simple hashing instead of TF-IDF and their let's say advantage and disadvantages, and then the project. So everything we'll try to quickly compile all those things in this video. Let's get started. Okay, so tokenization of words, right? So what's tokenization in case of a text document basically? Okay, so let's say what's a text document, right? So let's define a text first. So let's say I have a text. I want to learn NLP. That is why I have subscribed to your channel. I'm hoping that I'm typing correct spellings. Okay, but I also have opportunity to look into different YouTube videos for more understanding. So here we are getting a syntactical error. It's because it's a single line. Single quotations are always single line. So to make it multi-line, you have to make these changes. Okay, now you will not see an error. So my text is ready, right? So I can now print my text, right? So let's just print it, and you can see this is nothing but a simple text, right? Or string, basically. Sequence of words. Okay. Now, tokenization means creating tokens out of these words. Okay. That means, let's say a simple dictionary kind of thing that will keep all the vocabularies or all the words with their counts. Okay. And then we will use that dictionary to tokenize the strings. That's what we are going to do. Okay, so this whole sentence will get replaced with numbers. Okay, and that numbers have some vocabulary. Uh, I mean that numbers have linkage with some vocabularies. Okay, so for doing this, we need NLTK module in Python for working with this text. Okay, so first thing first, we have to import. So let's NLTK. So I'll hope if you don't have NLTK basically, so from your environment, you have to do this pip install NLTK. Okay, so as I have already installed, so you can see all the requirements are satisfied. Okay, so that in NLTK we have a tokenizer. So I have this tokenize. So as you can see, it's auto compiled, right? So this tokenize. So from this tokenize, I can do two types of tokenization. One is word. So let's say I want this word tokenize, and I can also do sentence. Okay. So sentence tokenizer. So after importing, I have defined my text, right? So let's say I just want to tokenize the sentence. So just use this function sentence tokenizer, and then what we'll do, we'll pass the text, and that's it. It will tokenize the sentence, right? Okay, now once you will start using all of this, you will start getting the errors. Okay, as there's a fresh environment, so I haven't installed anything. So now as you can see, so it is trying to load tokenizer punkt english.pickle file. So it is not getting it. Okay. So for which we need to NLT use this basically command to download this folder basically that will have this english.pickle module or model basically, and this model is why it is important to use this sentence tokenizer. Okay, so I'll just quickly again create another cell here where I need to import NLTK, and I'll paste that link. And okay, I'm running it now. So once it will be successful, then once we'll run, it will run as smooth as it is, okay, as it needs to. So as you can see, after a lot of attempts, okay, I'm able to download. So probably some network issue happened from my end. Okay, so once you have this required resource that's required this punct for your sentiment tokenization, then you can use this function, right? And once it is done, so you can see how the tokenization happens, right? Tokenization is nothing but uh, creating a separate list of tokens. So we have used the sentiment tokenization. So that's why, as you can see in the text, right, it has three sentence. It created three separate tokens, and one token contains one sentence. So now if I use a word tokenization for the same text, so how it will be done, the same thing, we'll be using the word tokenization, and then we'll be passing the text. Okay, and once that's done, we'll just let's print the words. So as you can see, I want to learn NLP, so I want to learn NLP, then the full stop. Okay, and then that is why I have subscribed to your channel. Okay, so as you can see, all the words, right, has been tokened for you and kept on in a list. So you can do the same thing basically what it is doing by only going through all the words of a sentence, and then you just pick all the words, run a for loop, and store that in a list. So that's a basic thing you will require in most of the traditional NLP works, right? You'll be using NLTK, and the first thing you'll be doing is tokenization. Next, one of important things that we'll do, that we want to remove some unwanted features from our files. Okay, so that's another important thing that we want to do, and will be using NLTK for this. So let's, in the second part, what we'll need. So we need this corpus module, and from this we need to import stop words. Again, it will fail probably, and we also need punctuations. So for punctuations, we can refer to string. So once this two is done, I'm again okay. Sorry. Okay, there's no error, right? It's typing error only. So once this is done, then we'll need to get the list of stop words. Okay, so let's. So we have this stop words module imported, and we want all the English stop words to be part of our list. So we'll be passing this. Okay. So as I said, you have to again install basically. So what you can do, you can NLTK download, uh, and you can pass all for downloading all. Okay, I'm now Only downloading this. So now as you can see, we have our stop words imported. So I can see now what are the stop words. So as you can see, this is the whole list of stop words. And if I do a len, it will give me the length of the stop words. So these are the stop words that's most commonly occurred in English language or English documents basically. So there is around 180 words are there. So I also want to add all the punctuations that normally we get in English. Okay, so let's make that also list of the punctuations, and as you can see, this is all the punctuations that we normally see. Okay, so I'll just need to control C and do a concatenation. So okay, list object has no. Okay, list object has no attribute. Okay, I'll just remove it from here for now. Okay, I think stopwords has already been generated, right? And that's why it is throwing in the error. Got it. Okay. So my stopwords are ready. And then what I'll do, I have my stopwords plus I'll just add this punctuation list to it. Okay, and we have all the files, all the files with us. And what we're gonna do, we're gonna make it as a set. Okay, so set will ensure that if there is any duplication, just remove all those. Okay, and it's unordered, so there is no order. So let's call it as custom list. And now I have this custom list with us. And now I'll get the word list. So remember, we have got all the words from here, right? By using this word tokenization, right? So we'll just need to write a simple uh, list comprehensions, right? To get all the words that is not included in the stop words basically. So I need all the word for word in word words basically. If my word is not present in my, I have misspelled custom spelling. Let's just correct it because we're doing linguistic, right? So English is important. Custom list. Okay. And as you can see, now we have all the words o- of the sentence basically without, I mean, we won't have all the stop words in it. So now you can see I want learn NLP and the two is removed because it's in the stop words. Okay, and if I compare now, let's say just copy it, the length of my sentence, which was previously 30, has shrinked a huge. So the number of processes, so the number of processing, right, is going to reduce, right? So this is very much important in any NLP project that we are going to do in the upcomings. Okay. Now let's move on. Let's now understand what's n-gram. So n-gram is nothing but, let's say I have this learn word, right? So in learn word, if I see how many single character word I can form, right? I can form five. So I can form Learn. So in 5 ways, right? So that is your 1 gram. Now your 2 gram will be, let's say, LEEA, then you have AR, then you have RN. Okay, so 4 ways. Then your 3 gram will be LEA, EAR, ARN, 3 ways, right? So 3 combinations. So basically it's permutation computations. So this is basically combinations of words in sequence. And why it is important? So let's say I go to Google and I start typing str. So it is giving me suggestions, right? So this is why it is important, or this is one of the applications of this engrams. So for engrams also we are going to use NLTK, and we are going to use this collocations, basically this module, and from here we are going to import bigram collocation finder. So this is what we'll be requiring. So let's find it as a variable, use the function, and then use from words, and let's pass our word list. Okay, and that's it. And once it is done, let's print our. So I just want to print the items. So you can find all the items, right? So as you can see, so it is giving us all the engrams and the default values we can definitely check here. So if I do a quick Google search, so you can find details about this bigram collocation finders, and you can see all the methods that you can use. So what we have used here, basically we have used from words, right? This from words method. So you can check this from words and you can get all the details what it is to. So it constructs a bigram collocation finder for all bigrams, right, in the above sequence. So we have a window size of 2, right? So we just know learn that we have a window size of 2, right, which is default, right, for that this from words. So let's just use this window size and let's convert it to 3, and again let's try to print our findings. So you can see the difference of the dictionary items, right? Previously it was very less, okay, in the dictionary item, and now you can see it is the result got changed, right? So this is another important thing that we have to do, and we have to understand what's engram is basically. So right now I hope that you can understand what's an engram, and if you have understood what's an engram, I will ask you to tell me, if I am using a unigram, right, that means 1 gram only, what will be the number of outputs for I, and what will be the number of output for look. So comment in the comment section. So let's quickly move on. The next thing what we're gonna do a stemming process. So stemming process is nothing but converting your understanding to understand. So stemming means it's if you see functionally, right, what it does, it just stems out. So it will give you the root word so that the whether no matter what past of I mean what tense you are using it, in which portion of the sentence you are using that word, basically what it does actually, it stems the main word and it conserves the context or it conserves the meaning, right? Okay, if you are saying that I am running or I ran, both thing in both the sentence, basically you are running. Okay, maybe the tense was past or maybe the tense was continuous or future perfect or whatever, right? But the main idea is conserved, or the main understanding, right? What you want to convey to your uh, I mean, what you can say, listener, right? Ki what you want to say basically is basically your root word. So that's the thing. It is, I mean, that stemming what comes from, and that we will gonna use this stemming just to get idea or just to extract that root word from that words, basically, right? So how to do stemming here also? You have to use this NLTK. So let's say for my NLTK, I'm going to use this STEM module, and within this STEM module, we have a lot of features, right? So I'm just gonna use, let's say, land scatter, right? This one. Yep. So you can also use different stemmer basically. So there are a lot of stemmers available, right? You have seen just. And once this is installed, let's just initiate this within a variable. And once this is done, let's do a stemming of our words. Okay, for word list, right? And let's just print this. So you'll see. So see your subscribed, right? Has shortened to subscribe, and that E also got removed. Your opportunity has been converted to opportune. Okay, so that's the stem, and we are using this module, okay, to do the stemming. So this is also very much important when you are doing NLP and pre-processing of text, right? So next in our bucket list is, let's say we are going to do what's WSD, right? So the next problem will be your WSD. So WSD stands for word sense disambiguation. That means, let me type it out, word sense disambiguation. So what is practically, let's say, uh, you have a word mouse. Okay, so you can use it differently, right? So a mouse, when you are writing it in context of computer, it is uh, conserving the meaning of a mouse of related to computer. And let's say you are using it in a cat story, that means that time a mouse is a living creature, right? So that's what this word sense disambiguation is. So for using it, again we need an LTK, and we need this corpus function basically, and we need wordnet so that it can install all the required words. And once we have that, so we, let's say, find out some, So I have my wordnet dot, let's say, system sets. I have the word, let's say, birds. Okay, and just going to printing this SS and the definition. So it's another method. Okay, it's synchronized. Okay, so as you can see, uh, this is the definition for birds it finds from WordNet. Okay, now, so how to perform this WSD? I'm just giving you one small example. So I'm going to use this WSD module for it. SK, and then we need to again import tokenize. Okay, what tokenize? We have already imported it here, right? From tokenize. Same thing we are again doing. So let's say I'm going to word tokenize. I'm going to use the same. Let's say that is why I have subscribed to your channel. Let's control C this one and tokenize that string. And once it is tokenized, I'm going to use the subscribed word to understand the context basically, and for that I'm going to use this less function. Oops. Okay, so if I do this, you see a sysnet function is a sysnet variable or output is basically created. So let's store it into as the context, and in the next thing what I want my context. Okay, so first let's store it, and I want this context, and let's say then I want, so you can see you can use various kind of methods from this. Okay, so what I want from this, I want similarities, I want, the first thing will be my definition, right? I want definition. So you can see what this subscribe means here in this sentence is basically offer to buy as of stock or share or something. It is understood that okay, subscription means purchasing on a regular interval or something like that. Okay, now let's move on to our next concept that we have planned here, and that will be my count vectorization. And again, this count vectorization is nothing but making your text as a vector so that your machine learning model or your deep learning model, whatever you are going to use, can understand, okay, it's a vector, it is coming into us, and we can definitely process it. Okay, so for this, let's say import pandas as pd need pandas. Okay, and let's create a corpus of list. Same thing, right? Let's copy paste. That's why I have subscribed to your channel again. And the third one, let's say channel few days back. Okay, so there's three lines. I think it will be fine for understanding. And now let's create a data frame out of it. I hope you know how to create a data frame. And let's pass this corpus there. And now you can see this data frame using this head function. So as we haven't passed any column names, right? So let's, if you pass column names, let's say text, and you see it's converted into text. Okay, now for using count vectorization, we need sklearn or scikit-learn. So we'll be using that sklearn, and from that sklearn, I need feature extractors. So I'll be using this feature extraction, and for that, as we are dealing with text, we require text. So just remember in that way, or you can anytime Google, no issues. What I want to import my count vectorizer, so it will automatically come. Now my count v, let's say that's the function I'm just so we have this count vectorizer, right? So first thing that you have to initiate it as a variable. Once it is done, you have to use it, that means your variable, and then you have to use the properties, and I want to do a fit transform. It's simple like a scalar, right? So standard scalar function. So I have this, my df as a text module, right? My df has a text column. So I'm going to transform that, and then whatever output I'm going to get, I'm going to convert it into an array. So I'm going to use that. Mm, okay, okay, to array, and then let's just print this. So as you can see, now this is what our three lines, right? So all these three lines have been converted into a arrays of tokens basically. So vector basically, right? Now the next thing will be getting the feature names. Okay. So this is my count vectorizer, right? So I'm going to use that same thing dot get feature names. That will give me all the feature names. So as you can see, the first one is again back channel days few have is subscribed that to why your. Okay, and you can also check the vocabulary. Let's check that. So you can check the vocabulary, okay, how much count it has for all the keys. So that's what your count vectorizer is. Now the next one is your TF-IDF. So I hope you already know what's the TF-IDF is. Basically, your TF-IDF is term frequency inverse document frequency. So what it does basically, let's say you have corpus of documents, right? A lot of documents, 100, 200 and all. So out of this 100 and 200 documents, let's say some words like cricket. So all the documents are dealing with cricket, right? So it's repeating in all the documents. So what your TF IDF will do, your term frequency for every document will increase the valuation of cricket in every document, right? But as it is present in all the documents, so that word cricket might not be that much relevant, right? When you are going to compare that with the others, so it will reduce its importance. So it will threshold with the presence of that particular word or that particular text in all the documents. Okay, that's what it does. That's what basically a TF-IDF function did. So it thresholds the frequencies of any word that is present in all the documents. Okay, so if a word is present in most of all the documents, so it will reduce its importance. Okay, and that's how this function finds the uniqueness of different words, and it preserves the context. Okay, and find the importance. Okay, so same thing from where we have imported count vectorizer, we can use this TF-IDF documentation, TF-IDF vectorizer basically. So if I do a tab, so you can see there's two things. One is vectorizer, one is transformer. Okay, we need vectorizer for this case. Okay, so we already have our corpus here, right? So let's say my vector will be my TF-IDF vectorizer. Again, the same method, you have to initiate that function, and once it is initiated, so then you can use a fit method. Like in all the sklearn properties, we can use a fit method, and we are going to pass our corpus. So it accepts list. So what's the difference? Previously you see that it is accepting a numpy array basically, or column of your data frame. Okay, so if I do, let's say, that's much more important what it is accepting. Type of df.text, so you can see it's a series, so it is accepting a series, right? And here it is accepting a list. Okay, so now you can see that we have fitted. Now for this vectorizer, right, vector, I can get all the vocabularies again. So you can see the vocabularies which you can also see here, right? The same vocabularies it is giving you. And again, what I can see, which is much more important, is my IDFs. So you can see this is the IDF values. Okay, so if you want to know much more about TF-IDFs, I'll suggest go and read some articles on TF-IDF, probably, understanding how it works and what's the formula basically it is going to use. So this is how it is getting calculated, this TF cross IDF function. Okay, so yeah, you can go and definitely check out this formula. Okay, so these are the normal things that we do in pre-processing basically. Okay, of any NLP traditional methods. So without further ado, let's just quickly move on to our project. So for that project, what we are going to do, we're going to use Hugging Face as dataset module. So let's say just first write all of this external auto reload. And once it is done, from datasets import load. So this datasets is a basic module of provided by Hugging Face. So I'm going to use their load dataset method, And once that's done, I need my numpy as well. That's done. I need some files. Okay. So as you can see in my folder here, I have a couple of files available, right? This data cache is a folder, and within it I have some files. Okay. So we are going to use this to JSON basically for processing our project. So let's just give that folder. So just copy this one. It will find this data cache slash this one and this. In similar fashion, we are going to copy this one again. Control C, Control V, and let's have to complete this one. And let's change its name to, okay. Right, so we have the names of these JSON files. Now we have to load JSON files, right, in Python. So we have one module called JSON for importing or working with JSONs. So let's import that, and let's say for file in my this folders, basically JSON files. Okay, so we have train files, right? So for file in train files, what I'm gonna do first, again, same, I'm going to open my file in a read mode, and I'm particularly going to mention that encoding is UTF-8. So I think UTF-8 we need to mention in this way. Okay, let's use as handle, create one variable json.load that file. Okay, and once it is done, let's just print it. No such file or directory. So where it goes wrong? Okay, so you have seen, right, this after data cache you have to give this slash. So that's where it is not finding the path. So now I think it will work, and you can see it can load all the JSON, right? So this contains all the text that we have. So now we don't want actually to print the data. What we want is coming out of this loop and create one text column, basically. So one list will be there, that so our data f is basically my data file, and for that I using this k, and for this I'm going to use the sentences, right? For dot keys, right? So within this data f dot keys, right, as you can see, this JSONs are nothing but the dictionary, right? All this from the starting. So just extract the keys. So this one is a key and there will be two is a key, right? So extract the sentence and give me that sentence, right? So that what we want. And let's create one empty list first. Name it as train text. And once you will get this text, what I'm going to do, I'm going to load this. So my train text dot extend is a function. You can also do append. And what I'm trying to append here is my data f text, right? So let's test that whether it works or not. And so you can see my train text contains all the text. So this is all the text that we have in that JSON. So that means it is working, right? So let's do the same for the levels as well. So okay, now again I want my levels for my sentiments, right? So what we are extracting for this JSON, so have you gone, I'll encourage you people to go through the JSONs, right? It contains your sentence basically, and it contains the levels, okay, for sentiment analysis, nothing else, okay? So what we can do, same thing, right? So I have this data F, and then again K for keys, okay? So let's type it out for K in data F dot keys, right? And as we are using a list comprehension, we have to use a list, okay? Now we have extracted the sentiments, sorry, sentence. Here I'm going to extract the info, okay? And again, just like this train text, I want a train levels, okay? And let's just see for now what it contains. So my data labels will get appended inside this train levels, right? That's what we're trying to do. So let's run it. It is running. Okay, now can see the train levels. So you can see we have this list under list, right? So we have snippets, we have targets, and we have sentiment scores, right? So what we want here now, if I select the first index, what we are getting one less amount of brackets basically, right? So we're getting all the elements. Now what I want from this, I want this sentiment score, okay? So this is how you have to write custom codes, right? I hope you already knows. And now I am getting all the sentiment score, as you can see here, okay? So once this is done, I can come out of this for loop and I can create one train text, and I can create one train level. So these two are basically my list, right? This train text and train levels. So I can create train text and train levels as numpy array, and I can pass whatever I get, right? So it will create an array from the list. Same thing, just control C and control V here, and train levels, right? And now if I see, so I'll have an numpy array. Okay, so once this is we have, what now we need to do? We need a threshold. Okay, so let's create, I mean, we have to convert this sentiment scores, right? That means what the levelings we are getting here to some sort of positive, negative, and neutral values. Okay, so that's what we are going to do in the next set of codes. So let's just create a function called sentiment score, and here what it will accept the array, right? That means your train levels, so which are nothing but scores. So I'm not going to write much here. Simple will be my zeros will be, let's say, -1 will be neutral, and 2 will be positive. Okay, so these things I need to first embed or append basically within side of a empty list. So let's just score in score. So whatever scores will be there, right? That means my 0.374, 0.24, 0.161, right? All this. So for score in scores, if my score is less than, let's say, 0.2, then levels dot append, let's say I'm making it as a negative comment. Okay, else if is my score is greater than, let's say, 0.2, what we can do, we can make it as a positive comment. Okay, and in between my logic will be levels dot append 1, and once it is done, as we are dealing with a data science project, we are not going to return a list, we are going to return an array of whatever we have created, right? That means that levels. So, okay, so once this is done, now we have to create levels. So let's create all levels as use this function sentiment score, and let's pass train levels, right? Okay, so as you can see, what it is saying that we cannot use this comparison for a float and a string. Okay, so it is assumption that it is throwing a string. Okay, no issues. We'll just make it as float here. Oops, this float needs to be inside this, right? Yep. And it will work. Yep. Okay, so let's just see np dot sum how many of negative comments we have. All levels equals to 0. So we have 505 comments that's negative. And let's see for the positive or neutral ones. We don't have any neutral one. Okay. And we have 606 positive comments basically. Why this is happening? This is happening because we have used a score. So what we have to do, we have to use a minus sign here, and again we have to rerun. And now you see, okay, yes, we have the values. So we have more positive reviews, less negative reviews, and very less neutral reviews. Okay, so again, this is an unbalanced data set. Okay, so we have our train test now, train levels now, and we have our levels converted into uh, positive, negative, and neutral sentiments. So now in the next module, what we are going to do, we are going to split it in training test and validation instance, and we're going to use those instance for applying whatever we have learned in this above things, right? So we are going to apply this tokenization, stemming, count vectorization, TF-IDF, and all this. Okay, in the next set of modules. Okay, so now we have our train text. So let's just quickly check the length. Okay, because going forward, that's the only important thing to distribute the text as training, validation, and testing set and length of my levels. Right, so all levels. Okay, so you can see that it is matching, it is 1111. So that's okay, and we can go forward. So for splitting it into test, train, and validation dataset, we required sklearn's model selection from sklearn dot model selection import. So we required this train test splits basically, and once that is import, we need four variables for holding the levels as well as features. Okay, so my train doc will be one thing, and the next thing will be my test doc, and then again my train levels and test levels. And I'm going to train test split that I just imported. I'll be passing my train text as my features, all levels as my levels, and let's say I want to keep my test size as 0.2, that means 20%, and let's I want to do a stratification for all the levels. Okay, and let's just run it, and let's just print the lengths of my training and testing data. So length of my train doc and length of my test doc. You can see, so it has split it on a 80-20 ratio. So let's just move on with the work that we have to now perform. So let's, what we're gonna do, we'll first create a data frame out of it. Okay, so let's say train data frame will be pd dot same thing data frame, and within that we'll be passing the keys as documents, and my documents will be train docs, and we'll also have levels, and that levels will be my train levels. Okay, so mm, train doc and train levels are not equal. Okay, let's just quickly verify that also. It's 888 right? So where we are missing, all arrays must be of same length. Okay. Hmm. Let's just verify what's inside it. Okay, it's nothing but my array only. Interesting. So it's failing. Okay, guys, I need to check where it is failing basically. So it says missing dictionary with non-series may lead to ambiguous ordering. Okay, guys, so why we were facing this error? Because of a silly typo here. So that's why, like, if you see this, right? So if I do, I'll get a value of 888 now. So previously we were getting a 1111. So that error was happening because of this train levels, right? So this variable, we have train levels, and here also we have used train levels, right? So that's why we were getting one execution error. So now I think it's resolved. So if I use this dictionary, I can build one data frame out of this dictionary, and yes, now I can build the data frame out of the dictionary, which will have 888 values or 88 rows. And now if I do a head, I can see my document and my level. Okay, so that's working fine. Right, now next thing we'll have to do, we have to import all the required mm, modules for processing, like whatever processes we have done here with the text. Right now we want to do a bunch of text, and then we'll just perform some visualizations probably, and we'll end that pre-processing step here. And in next set of videos we'll come up with more step-by-step guides for NLPs, and it will be consequentials. Okay, so now we are going to create the same data set for test documents as well. So here the train will get replaced with text. Test levels not defined. Okay, I think it's Label. Okay, that's where it got error, right? Yeah. So again, let's create a test df, and now we have our test df as well, and we can see it. Yep. Now what we can do, we can concatenate this two for getting a full data frame. So how to concat? We are going to use pd.concat function where we'll be passing what we want to concat. That means we want our train and test. Okay, and I don't want the index to be noted, so I'll just tell my method to ignore the indexes, and once this is done, let's just copy this as process review equals to full df dot copy. We also have a deep copy. Can you tell any one of you what's the difference between copy and deep copy? Comment below, right? So now what we can see, first thing is an a dot sum. So it will give me whether I have any null values. So as you can see, we have created from a document, right? All of this. So there is no null values. Okay. So first thing what we can do, we can see particularly, let's just visualize one document. So one values. So this train text, right? So let's just take one document at a time, and we see we have casing, lower casing, upper casing. So first thing we can convert it uh, basically a text to a lower. So how to do that? I think if you use a lower function, right, it will work. Right, as you can see, everything now converted to lower. Okay, that's the first thing we can do, and then we can replace all the punctuations. Okay, let's get one punctuation here or things like that. So the first thing, okay, let's create one definition of clean text, and it will take a string. Okay, that means which will be my text. And how to clean? Let's say my text equals to the first thing. Let's make it a string and dot lower function, right? So that's the first thing. And then return that text. Okay, now I have my data frame. Process review has two parts, right? Documents. So my process review documents will be writing one lambda function here for applying this function we just created. So apply and apply lambda. Let's x will be clean text x, right? And it will work definitely. Now let's just visualize whether all my document is lowered or not. You can see everything is lowered, right? So just again just run your one time for you know comparison, and let's do it for 10 values. So as you can see now all my values are lowered here. Okay, now next what we can do, again we have to take the same text and we can use the RE module for regular expression, and for that we have to import this RE. So this regular expression is very much important when you are doing dealing any kind of text processing or string processing in Python basically, or in any other language for that matter, right? So let's substitute pay any kind of brackets, punctuation thing basically we want to eliminate from the text. Okay, backslash for understanding and replace with nothing in text. Okay, so this is done again, and again apply, and now see, now we can see. Okay, let's do it for 10. So can you find any difference now between these two? So you need to find a okay, now what I can see here, I can also see some HTTP and HTTPS kind of thing, so we can remove that as well. So I'm going to use this pattern HTTP, let's say giving question mark. By the way, if you are not familiar with regular expression, right, I will suggest you to do check in any standard documentation or any tutorial. I think that will work. And this is for escape character, to understand that dot is not to escape, it is something that we're looking for. And again an S plus, and if it finds this pattern, let's replace with nothing and pass text again and return it. And now if we again apply, we'll see that the HTTP is now removed, right? So HTTP was there in third number index. Now the third number index is yummy long setup closed above, right? Yeah, so you see this whole HTTP pattern is got removed now. Now next, let's dig further and eliminate more. This time I'm just going to do a copy paste, and let's say I want to use a pattern like this that I've just figured out. And I want this, right? So there is nothing to escape, and add whatever. So as you can see now, it's much more cleaner than the previous one. Now let's do something about the punctuations, right? So for that, let's use the percentage. Then let's say this percent, right? Let's use this escape function for escaping string dot punctuation. We have just used punctuation, right, in our tutorials, and replace it with nothing. Okay, string is not defined. Okay, import string, and you can see now we have this dot and percentage got removed, and all the punctuation, that means all this at the rates and dollar symbols got removed, right? Now this text is much more cleaner. Okay, and what we can also do, we can delete any kind of, let's say, new line characters also we don't want. And as a last step, what I'm thinking now, let's just get rid of this pattern as well. And now we can see we have a much cleaner text than what it was previously, right? I think you guys will agree here, right? Now we have also removed all this percentage and all these values, so these are irrelevant, right? For 6 number index, if you now read West or soda has a float, short, lol, all this stuff, right? So this is how we have applied the first thing, that's basically your removal of stop words. Sorry, no, we haven't done this processing stuff there, right? So that's something you have learned on strings, might be. Okay, now let's say I want to apply this stop word removals. So what I'm going to do, I'll just go here and copy this code. So here is a catch, right? So what this stop word removals will give you, it will give you all the words, right? After removing the stop words as a list of words and not as a string or as a sentence, right? But we want as a sentence. So we're going to use this custom list that we have, right? And again, we'll write a lambda function. So just copy this same line here again. And here it's a simple join. So join all my words for word in x dot split. Let's use the split function for splitting. If my word not in the same, right? Custom list. And I think this will work. And and this thing has to be a list comprehension. So now by this process I can get rid of all the stop words that's are there in the document. So can you spot any? I can see this on, right? It's got removed in this process. So this is how you need to do pre-processing for steps, text basically. Okay, now the next thing will be what we can do. We can stop here for this session, and in the next session we can dig deeper into all the NLP fundamentals. So here in this worksheet, or basically in this tutorial, what you have learned a lot of pre-processing steps basically, and a way to implement those. And in next step, I think we'll go dig deeper with the same set of example and same workbook, and we'll build further. So that's what what's left, right? This TF-IDF count, vectorizer, stemming, and all that. For that, watching those things and learning all these steps. Okay, stay tuned with me for the time. Bye bye.